So is this expression here for an area, length or a volume? Well, you should already recognise this because this is the formula for the circumference of a circle. But there's a certain set of rules that we follow to tell whether something is an area, length or volume. So first of all, we're going to cross out any of the constants. 2 is a constant, as is pi. They're both numbers, which we don't really need. So I'm left with just the r here, which is just one single variable, which on its own must represent a length. Since there's nothing else here, this entire expression must represent a length, which is exactly what the circumference is. Again, we should recognise this example. This is for the area of a circle, but we'll follow the same rules. I'll cross out the constant. So I'm left with just r squared, which is the same as having a length squared. So any length squared must just be an area. Again, we should recognise this formula. This is for the area of the trapezium. So let's get rid of the constants. A half. So in the middle here, we'll do the brackets next. We've got length plus length, which is just the same as having 2 lots of a length. In other words, it's still a length. And I've got to multiply that by h, which is another length. So this bit here is a length, and then I'm multiplying it by this length outside of the brackets. So I've got a length times a length, which is a length squared, which again, that must be an area, as we already knew at the start. Okay, so let's follow the same rules again. Let's get rid of my constant here, 2, which I don't need. A squared b is like having a length squared times by a length. And I'm going to add to that a length times a length times a length. L squared times L is a length cubed. I'm adding to that what is also the length cubed. A length cubed must be a volume. So this must be a volume, this must be a volume. So I'm just going to add the 2 things together. It's still going to give me a volume. Volume out of volume, still going to be a volume. Again here, let's get rid of my constants, 2 and pi. So I've got r squared h. R squared is the length squared times by height, which is another length. So that is length cubed. A length cubed, again, as we saw a second ago, is a volume. Again, let's get rid of the constant 3. I've got x squared, which is my length squared, and times by y, which must be a length on its own, and then by z, which is also a length. L squared times L is L cubed, times by L again is L to the power of 4. Is that a length, area or volume? Well, it's none of the above. It's a trick question really. It's nothing. It's what you call inconsistent. Next one here, get rid of my term in the middle, and this one, don't need those constants. PQ is a length times a length, which will be a length squared, so that represents an area. This is just a length on its own, and TV, again, is going to represent an area. Now, this situation is a little bit more difficult to recognise. You can't add together a length squared, which is an area, and a length. You can't add a length and an area together. So this is none of them. And this one actually is inconsistent, because you can't add together different units. So you can't add together a volume and a length, or you can't add together a volume and an area, because they're different things. Final one, again, let's cross out the constants. Pz squared on the top, well, z squared is an area times by p, so that is going to be a volume on the top, and I've just got length on the bottom. Well, the length cubed divided by length reduces it to being a length squared, so the whole thing is an expression for an area.